Hi everyone, welcome to our first math lesson of week 3. So today we're going to be talking about modeling with algebra. And basically, modeling with algebra, all that means is that we are going to be taking words and making an equation. Okay, so our goal today is to make equations. Okay, so essentially what's going to happen here is we are going to read through the questions. So I'll read them out loud and then I'm going to highlight the key information. So if you're copying these questions down into your notebook, you may also want to use a highlighter or a different color to kind of indicate some of the key information. So the first example is Mr. Jang operates a variety store with his sons, Jerry and Coco. Jerry makes twice as much money as Coco, who only works part-time. Mr. Jang makes $200 per week more than Jerry. The total weekly payroll, so this is how much they pay out altogether, is $1,450. How much does each family member earn per week? So basically, the key information that we have here is that we know that Jerry makes twice as much as Coco. Okay, so that's important. Jerry makes twice as much money as Coco. And then we also know that Mr. Jang makes $200 more per week than Jerry. And the last key piece of information here is that the store spends $1,450 on payroll every week. And now we want to know kind of how much each person makes. So the first step to this is always making statements so that we're going to assign letters with people or letters with ideas here. So the idea is, that we need to tell people or me or you or your family or whoever's reading your work what each letter means, okay? So to do this, we are going to make an algebraic expression. So we are making an algebraic expression. Okay. And I'm going to, you can assign any letter, but I'm going to let K be Coco's earnings. And the idea is that we only want to have one letter in all of our equations so that we can solve them. Okay, as soon as we have more than one letter, so if I were to assign a different letter to different people, we couldn't solve that, but we can solve things with one letter. That's what we've been doing. So I'm going to set up a table here, and we don't always have to set up a table, but basically, so this is going to be the worker, our expression, so how we're using that letter, and our explanation. That's an A. Okay, so we are explaining what we're doing. Okay, so in here, our worker, our very first worker, that's going to be Coco. We said that the expression is going to be K, and this is basically we don't know what his earnings are, so Coco's earnings are unknown. We don't know that yet. Okay, and then now let's talk about Jerry, because we had no information in this about what Jerry's earning or what Coco's earnings were, just that he made less than everybody else. So that's why we picked Coco to be our main person, because he made the fewest amount. That's going to be our base unit here. So Jerry, we know that Jerry ended up making twice as much money as Coco, and that says that right here. That's that green. So Jerry makes twice as much money as Coco. So how can we represent that? So we know that Coco is K. And how do I represent twice as much of a letter? Well, I'm going to multiply it by 2. Okay, so twice as much is 2 times K. So Jerry makes 2 times more than Coco. Okay, And then what about Mr. Jang here? Well, there was some information about Mr. Jang too. It said that Mr. Jang makes $200 per week more than Jerry. So I know that Mr. Jang, oops, sorry, writing too close to the toolbar. So I know that Mr. Jang is going to make the same amount as Jerry, so that's 2 times K, but then he makes a little bit extra, which is that $200, so plus 200. Okay, so he earns And so this is kind of how we're going to set up our equation right now. I know that at the end of the week, so I know that my whole equation is going to have to equal the total amount of money spent on payroll, which was $1,450. Okay. And I know that my payroll is just the 3 people added together. So I'm going to have Coco's earnings, which were K, plus Jerry's earnings, which were 2K, plus Mr. Jang's earnings, which were 2K plus 200. Okay, and that's where I'm getting all of these from. So if I'm looking at this equation right now, I see a lot of K's and I see some numbers and some other numbers, but I know that I can rearrange this so that I only have K's on one side, numbers on the other. So I'm going to simplify first, and specifically, we are going to simplify all of these K's. We're going to make all of these K's into one bundle. So if I do 2K plus 2K, that's 4K's, plus one more K, so 2K plus 2K is 4K's, plus 1K, that's 5K's. So I have 5K's on my left-hand side plus 200, and all of this equals 1,450. Now I want my K's to stay on my left-hand side. I want my numbers to go to my right-hand side. So to do that, I'm going to take this adding, and I'm going to subtract it to the other side. Because subtracting is the opposite of adding. And I'm running out of room, typical Mrs. C fashion, so we're going to carry on up here. 1,450 minus 200, that's going to leave me with 1,250. Okay. And if I'm looking here now, this is saying that 5K's are equal to 1,250. I want to know what 1K is equal to, so I'm going to divide both sides by this 5. And then you guys using your calculators, pull them out. We're going to do 1,250 divided by 5, which is going to equal $250. Okay, so we're almost there. So we know now that Coco is going to make, if I go back up to my table, Coco makes $250. Okay, not very much. But I want to know now what Jerry makes. And Jerry, we said, is 2 times K here. So this is going to be 2 times 250, which is 500. So Jerry makes $500. And then I know that Mr. Jang, he's going to make $200 more than Jerry. So then this is going to be 500 plus 200, which is 700. Okay. So now we've figured out what everybody makes here. Okay, so again, Coco's going to make 250. Jerry's making 500. And Mr. Jang's making 700 here. So let's go into the next example, and you can decide whether or not you want to keep making this table or you don't want to. First, I guess I'll read the question, and then we can kind of go through. Oops, didn't mean to do that, just jokes. Go through, and I'll make it larger so I have a bigger space. So Uma works at a ballpark selling peanuts. She is paid $6 an hour plus 50 cents commission for every bag of peanuts she sells. We want to find Uma's earnings if she sells 42 bags of peanuts during a 4-hour shift. Okay, so some key information here. I know that she's going to make $6 an hour, and then for each bag of peanuts she sells, she makes 50 cents. Okay, so those are some key parts of that question. So let's look at this. So she sells 42 bags of peanuts during a 4-hour shift. That's pretty good. So if I'm doing this, we need to come up with a variable. So let's make a table, I guess. So I have my earnings, just like I said that we would do. Pen's not working. So I have my earnings. Okay. So the way that Uma is going to make money is by an hourly wage, right? And we know that if we're looking at hourly wage, we can pick our variable H. And the expression here is going to be 6 times every hour because she makes $6 per hour. Okay. And then she also makes commission, which is great because $6 an hour is not very much money. And commission, there's 2 M's in commission, my bad. So commission means that for each bag, you're given some sort of money. So an incentive to sell. So let's make that P. And because of peanuts, so for every bag of peanuts that she sells, she makes 50 cents. So that's 50 cents, 0.5, right? 50 cents times each bag of peanuts. Okay, so those are our variables here. We might want to do one more, which is E, and E is just going to be, sorry, messed that up again. E is just going to be our total earnings, okay, so how much she makes altogether. And so our total earnings here, so how much she actually makes, we're going to represent by E. Okay, so our total earnings are basically going to be the amount of hours that she works, so 6 times H, plus however much she makes per bag of peanuts. So once I kind of get this ball rolling here, I now have this equation. So we can see that this is the equation that I'm going to use. And instead of having it in a table format like now, let's actually do E equals 6H plus 0.5P. Okay. And I know I can do substitution. I know that she's actually working for 4 hours. So instead of an H, so she's working for 4 hours and she sells 42 bags of peanuts. So instead of an H, I'm going to replace that with a 4. Okay, because that's how many hours she's working. So 6 times 4. And instead of a P, I'm going to replace that with a 42. So 6 times 4, that's going to give me 24. And half of 42, or 0.5 times 42, that's 21. So her earnings for this whole thing is going to be $45. So in 4 hours, Uma earns $45. Okay? And so I just did some simple substitution here with my hours and the bags of peanuts. So that's what I've put in here each time. And then I added them together because that was the operation. And Uma, again, is earning 45 hours in that amount of time. Okay? So let's finish up with this example here. We'll just do this example, and then that'll be it for today. You can do a couple of practice problems. It's saying, how many bags of peanuts must she sell in order to earn $100 in 7 hours? So I have my equation that we did the hard work with in question 1. So I know my equation is earnings equals $6 per hour plus 50 cents per bag of peanuts. Only we have some different information here. So for instance, we know now that she wants to earn, so my E needs to be $100 and my H is 7. Sorry, I was going to write out 7. Going crazy here. This lockdown. So really what's left here, if I have an E, I have an h. I'm looking for my p, so my p is unknown, okay? So I'm going to substitute the things that I know into my equation. So instead of an e, I know that that can be 100. And instead of an h, I know that that can be 7 plus 0.5p. So this is what I'm looking for. So I'm going to simplify what I can. So on my left-hand side, I still only have 100. On my right-hand side, 6 times 7, that's 42, plus 0.5p. Okay, so now I have all of this, and I'm going to now need to get rid of everything so that I have p by itself. So if I'm looking here, on my right-hand side, I have 42 plus 0.5p. I'm going to keep my p on my right-hand side of the equation. I'm going to move this 42 over, and to do that, it's positive, and the opposite of positive is negative. So I'm going to subtract 42 from the left-hand side of my equation, and that's all going to equal 0.5p. Now, 100 minus 42, and there was that in-between step here, which I kind of skipped, which you guys can start skipping if you feel comfortable doing it, and this was that step that I've just now written in. So you don't have to write this middle step because I know that 42 minus 42 is going to go to 0 on this side. Okay, so I have no more numbers here. So I'm left with 100 minus 42 equals 0.5 times p. So 100 minus 42, so you pull out your calculators, you can do that. Oops, didn't mean to enlarge the screen. That's going to be 58, 0.5p. Okay, and I'm timesing by 0.5 on my right-hand side. And I want to get rid of that because I want to know what 1p equals. So to get rid of timesing, I'm going to divide both sides by 0.5. And you're actually going to get a bigger number. So whenever I divide by 0.5, whenever I divide by a decimal, you end up getting a larger number as long as there's no whole number. So as long as you're only dividing by a decimal, you will get a bigger number. So here, instead of 58, I'm going to end up with 116. My 5.5's cancel out, and that leaves me with p. So basically, what does this mean? This means that in order for Uma to make $100 in 7 hours, she needs to sell 116 bags of peanuts. So therefore, that's what these 3 dots mean. This is my therefore. Uma to make $100 in 7 hours. Okay? Okay, so this is modeling equations. So basically, instead of doing this next example, I'm going to write out some steps that make modeling equations easier. So the first thing you're going to do is identify the key pieces of information from the question. The next step is you're going to make some sort of let statement where you tell us what the variables mean. Okay? And then you're going to start to build your equation. Kind of like Build-A-Bear. So you should be making equations that only have one variable in them. Okay, so goal, our squad goal for today. Make equations with one variable. All right, well, I hope that you guys have enjoyed this super awesome lesson, and I can't wait to see you guys again or talk to you again. Keep checking in with me. Let me know how it goes. Don't forget to type any questions into that Google Doc. Have a great day.